Hi, this is now looking at Chapter 2 in Psychology 2. We're going to look at intelligence, cognition, and language. Now, what we're going to start off with on this first week here is look at cognition, problem solving, and we're going to touch on language a bit. And then the next one we'll do will be on intelligence and creativity. Okay, now when I was thinking about intelligence, it's probably something that we could get a little confused about, and we'll touch on this in the second video, but I'm going to introduce it now. I may repeat this in the second video. Wendy is a person who has what's called Williams syndrome. And Wendy has a very rich vocabulary. She enjoys telling stories. When you meet her and talk with her, you probably understand she has some challenges, but for the most part, she's very dialogue-based and very comfortable to be with. But she has an IQ of 49, and we'll get later what that means in terms of competencies. She can't read. She can't print words beyond a grade 1 level. But she casts doubt then on what is intelligence. She can't read or write very well, and yet she can carry on a conversation very well. She has a very rich vocabulary. So it's not something, it's a disability in a sense. And then you look at someone like Kim Peeks. Now, you may not know the name Kim Peeks, but you might know the movie Rain Man. And Rain Man is a story about a real person by the name of Kim Peeks. And Kim is somebody who has a massive memory bank. He has no barriers to access to memory. So what he basically is able to do is that anything he reads, he remembers. He remembers about 98% of what he reads, and he reads rather in a unique way. He opens a book, left eye reads the left page, right eye reads the right page at the same time. You can ask him a question about anything he reads, and he'll answer it. Just like what you saw in the movie, he's quite remarkable. But he can't look after himself. His dad has been looking after him all of his life, making sure he showers, feeds him, shaves him, because he can't look after himself. So we have to ask yourself, what's intelligence? What's language? What's cognition? And we'll look at that in this chapter. All right? Let's get going. Now, cognition, we're going to start with. Cognition is the mental process involved in acquiring, storing, retrieving, and using information. These can include sensation, perception, imagery, concept formation, reasoning, decision-making, problem-solving, and language, all of which we're going to talk about in this week's video and next week's video. Now, when we talk about reasoning, we're talking about a form of thinking where conclusions are drawn from a set of facts. And so you reason out a conclusion based on a set of facts. Now, you don't have to have all the facts, but if you've got some facts and you start using your brain to figure out what do those facts mean, that's called reasoning. Now, there's two forms, reasoning by deduction and reasoning by induction. Reasoning by deduction is reasoning from general to specific. So drawing a particular conclusion from a general principle. Let's say we're looking at the general principle that colored petals on green bushes are flowers. Now, specifically, I might be able to conclude by looking at a variety of different flowers with petals what the names of these specific ones are because I understand that they are flowers. Whereas reasoning by induction, these are drawing conclusions from particular facts. And so it's kind of like an investigator. The investigator picks up bits and pieces of facts and then draws conclusions from that. And so when we look at cognition, we do our thinking, our reasoning from both sides. Some of it is from what we've learned in school, general concepts, and then we learn very specific things down, or from a little bits of detail and then sort out what does that mean. Now, some of the thinking tools, when we think about thinking tools, we can use the term cognition. Cognition, again, is this process involved in acquiring, storing, retrieving, and using information. And so in this, we talked about sensation and perception. We took that in Psychology 1. Imagery, we're going to look at here. concept formation, reasoning. We're going to look at decision making, problem solving, and language. So some of the tools for the act of thinking include imagery. And imagery is the representation in the mind of sensory experience. So we would be using our visual representation. If someone asks you to tell them how do I get from here to Toronto, you might be using some visual cues in your own mind, creating a visual map, if you will, to inform the person of how to get from here to Toronto. You might be using landmarks. And so you'll be using visual information. Now, auditory is another way that we could represent information. If you've been studying, sometimes people will use song to help them remember things. Gustatory is using your talking. Then you have motor or textile. So that's your touch. Olfactory is smell. And all of these senses we can use in terms of representing in our mind. You know, I just have to remind myself of the smell of home-baked bread to remember what that was like being at home and remembering my mom making homemade bread. And so imagery is what we do in our mind to represent other information and represent the sensory information. It's useful in learning or maintaining motor skills, and we could use this information to learn things, to think and organize in our minds. Now, concepts, these are mental categories used to represent a class or group of objects, people, organization, events, situations, or relations that share a common characteristic or attribute. So for example, a concept of furniture. You know what furniture is in your home, but you can differentiate different furniture, but you could also group in a category those things that are furniture and those things that are not furniture. When you have a concept of college and Georgian College, you know what sorts of things fit within the concept of Georgian College and what things would fit outside of Georgian College. You know what a tree is, what a dog is, but you also know what it's not. So you know how to categorize things and put things alike. And that's what a concept is. Concepts help us to order our world and to think and communicate with speed and efficiency. So if I see something new, I try to fit it into something I already know, into a concept I'm already familiar with. And if I can't, like what you'll do in some of your education and some of your classes will be, you're going to start to create a new category, and you're going to start collecting these examples of things that you're learning into this new category. Those of you in nursing have probably had a general understanding about the body, but chances are you're learning new things and having to create new categories, new concepts. Now, if we look at prototypes, a form of concept, these are examples that embody the most common and typical features of a concept. That's why they're called prototypes. Usually it fits closely with the natural concept. The prototype for bird involves robins and sparrows. Since they all can fly, and we might say that birds are flying, can fly, rather than penguins and emus that don't fly. So which of these birds best fits your prototype of the concept bird? And if you think about a prototype of car, what makes a car for you? Your prototype. If someone says, what's the best example of a car? Well, it has 4 wheels, it has 2 doors or 4 doors, it have a trunk in the back and a motor in the front, has headlights, and so you can sort of say that's what it is, but you won't mistake a car for a dump truck. You know there's a difference. And so a prototype is your best example. Now, exemplars, these are something a little bit more explicit. The individual instance or examples of a concept that are stored in memory from personal experience. So if I asked you for your exemplar for a car, it may not be the same as my exemplar for a car because my experience and yours with cars would be different. So if you work with penguins in a zoo your exemplar of a bird would be maybe a penguin. Someone who doesn't work in a zoo may use a bird they see, like a robin, as an exemplar for a bird. So people decide whether an item reflects a concept by comparing it with the most typical item of that concept that they have as an exemplar. Now, when we move into decision making, the process of considering alternatives and choosing among them, we have many examples. I'm only going to review a couple of them here. The first is a systematic decision making. This is where the process of considering alternatives and choosing among them. And so this is where you might say, well, I have to solve this problem. I have to make a decision between A, B, C, or D. And then by looking at the alternatives, A, B, C, and D, you make a decision about which of the 4 best represents what you think is the best solution. So you pick B and you act on B. That's a systematic decision-making process. Whereas in elimination by aspect, what you're doing here is, it's a decision-making approach in which the alternatives are evaluated against criteria. So if you're going to go, rent an apartment, you have some criteria. Well, it's got to be no more than $800. It's got to have parking. It's got to be near the college. It's got to have, close to a grocery store. I don't really want a roommate, but I need to know how much in relationship to do I need a roommate. So you've got this criteria, and you've ranked them according to importance. Well, it's most important for money and parking. So usually ranking from the most important to least important and making your choices based on what's most important. This is an elimination by aspect of decision making. So when we use our cognition, we use strategies. And we're going to look at a bunch of strategies here in terms of decision making. And we're going to take in a little bit of information here. These are in your textbook as well. Now, heuristics are a real important element. These are basically rules of thumb that are derived from experience and used in decision making and problem solving, even though there's no guarantee of its accuracy or usefulness. The decision to leave home to avoid getting stuck in traffic jam, though you don't know if there's even going to be one, but you make a choice based on the time and the likelihood that there will be one, so it's a heuristic in that you have a strategy, you don't know if it's going to work and if it's even necessary, but you will employ it. Now we use this in crossword puzzles, Sudoku, approaching school tasks, tests and assignments. You'll put together a strategy. You don't know whether your study strategy is going to work, but you use it, so you think it will. So that's a heuristic. Now there are 3 different heuristics we'll look at here: availability heuristic, representative heuristic, and recognition heuristic. I pulled these out for you because I want you to be aware that there's more than one sort of rule of thumb, and we use them under different conditions. The availability heuristic is a cognitive rule of thumb that says that the probability of an event or its importance assigned to it is based on its availability in memory. So the more recent something happens, the more likely I'm going to remember it. And so the decisions to leave home early to avoid traffic are because we were stuck in traffic one time recently. And so that's availability. It's just most recent. It's most available to me because it happened most recently. So how do you choose a fast food restaurant? Chances are you use a representative heuristic, a prototype that guides you based on your last experience about that. So we look at a representative. This is thinking strategy based on how closely a new object or situation is judged to resemble or match an existing prototype of that object or situation. And then lastly is the recognition heuristic. And this is a strategy in which decision making stops as soon as the factor that moves you forward in a decision has been recognized. You vote for a woman candidate simply because you see a female name on the ballot and you want a woman to win the election. So you see the woman's name, you click on it, you don't go any further to evaluate the candidates. That was the recognition heuristic. Now, there are lots of heuristics, and I'm only just highlighting to show you that there are more than one in terms of these quick, easy to use, and these are what we rely on. They're not necessarily infallible or even the best decision-making tool, but they are strategies that we use. Now, framing is a way, the way information is presented so that it emphasizes either a potential gain or a potential loss as the outcome. Positive framing leads people to prefer an option. Describing a cure as having 300 people, as saving 300 people will cause it to be favored over one that lists how many people are going to die. So the way you frame it, the way you sort of look at a problem will help you see the problem in a more favorable way or see it in a less favorable way. Now, intuition, and I've heard this described by a few people, or at least asking about intuition, it's rapidly formed judgments based on gut feelings or instincts. It's usually based on mental representations of the gist of the body of information rather than its actual facts. So, for example, you go into a dark room Sometimes you feel nothing, but sometimes you get a gut feeling that something's not right. It's usually that you have gained some sort of information that you're not otherwise aware of, but your body is aware of. Your cognitive, part of your sensation or sensory apparatus picked up some information that you weren't aware of. Functional fixedness is failure to use an object in a novel way, to solve problems because the tendency is to view the object only in terms of their customary function. If you look at the image there, you see somebody's trying to make some muffins maybe here, and they've got a beater, but they've got no beater wands here, so they put a set of scissors in and find themselves being able to do it. Now, somebody with functional fixedness wouldn't imagine using scissors that way because that's not what you use scissors for. But someone who does not have functional fixedness would use that as a solution, using it with a drill and a pair of scissors. This isn't how you'd normally use them. Now, one type of fixation in which individuals fail to solve a problem because they are fixated on the thing's usual function. And they don't have, if you don't have a regular carafe to catch the coffee, will you think of using another type of a bowl? Well, of course you might, but some people don't, and that would be a functional fixedness. Mental sets is a type of fixation in which the individual tries to solve a problem in a particular way that has worked in the past. Resistance to pay a bill online might result in from a mental set. Let's say you've always done things by mail, and so now you've been told you have to start doing things online. And you read the statement, you write the checks, you stamp the envelopes, and you put it in the mail as what your mental set has always been. You might struggle with doing it online because it doesn't seem to fit. It doesn't seem right. And now we're going to introduce language. And I'm just going over this. You have to go through your textbook to get some more information. So with language, a means of communicating thoughts and feelings using a system of socially shared but arbitrary symbols. These symbols could be sounds, signs, or written symbols arranged according to rules of grammar. Now, if you're going to be studying language, you are doing what's called psycholinguistics, a study of how language is acquired, produced, and used, and how the sounds and symbols of language are translated into meaning. So a psycholinguistic person is sort of investigating and looking at language. When you break language down into its bits and pieces, the phonemes are the smallest units of sound in the spoken language. The morphemes are the smallest units of meaning in the human language. And then the syntax is the aspects of grammar that specifies the rules for arranging and combining words to form phrases and sentences. So we're putting it from the simple sound to the simple smallest meaning, then to putting some of these sounds and meanings and words and combinations to create phrases and sentences. The semantics is the meaning or the study of meaning derived for phonemes, words, and sentences. So when we hear somebody say a word or a sentence, and the meaning we get from that is semantics, because we know that not all words mean exactly the same. It's context. And then pragmatics is the pattern of intonation and social rules associated with language. So for example, if I'm going to ask a question, my voice will go up at the end to reinforce that it's a question. How old are you? Are you going to dinner tonight? There's the sound of the voice going up and making the sound of a question. Whereas if I'm making a statement, I want to go down. Do you understand what I'm saying? And if I go down, I'm making more of a statement. It's more of a formal tone than by going up. And that's pragmatics. Now, when we look at language, where does it develop from? How do we get it going? And well, it starts very, very early. From a crying infant to some 80,000 words that a 17-year-old will have. And if we break it down into some stages, cooing and babbling would be the first stage, if you will. It's something in the second to third month where oohs and ahs, vowel sounds. And then at about 6 months, the beginning of babbling, where there will be combinations of consonants and vowels. Ma, 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 da, da, da would be babbling. At 8 months, the focus on rhythm and intonation of language, and an increased focus on the sounds of their native language. So up until 8 months of age, they would be able to learn any language. Because at that early stage, they're really just learning sounds, consonant vowel combinations, and start to pay attention to the rhythm of the native language that's in the room at the time. And if the room that was, if a child moved from being in my household to going into another cultural household, they were just as capable of learning that language. There's no English gene or, Chinese gene or Japanese gene or Indian gene. It's a language component. So a child is capable of learning any language that they are exposed to. The next stage is one-word stage. Sometime during that second year, the use of the words to communicate single words as whole sentences. So instead of saying, I want milk or where's the milk, you might just hear milk. And that's representative of something that the child has identified that they want. And then the next stage is two-word stage and telegraphic speech. Between 18 to 20 months, they'll have about 50 words, verbs and nouns and adjectives, and into two-word sentences. By 2 years old, they'll have somewhere in the neighborhood of 270 words. And then the last stage that takes quite a bit of time, and this is suffixes, function words, and grammatical rules, where children gradually begin to add modifiers and increase precision. So how do we acquire language? Well, there's a number of theories, and we're only going to touch on 3. Learning theory, just like with behaviors, as we talked about in Psychology 1, language is the same as other behaviors. We use reinforcers, imitation, correction, use of praise, giving attention and approval to reinforce the appropriate use of language. In the textbook, you'll notice there's some weaknesses related to learning theory regarding language. Now, nativist position is a unique position. It's not well researched yet, but there's a fair bit of work that's being explored in it where it looks at language as innate. We're born with the ability to speak. It suggests that there is an LAD, or a learning activation device, within the brain that enables children to acquire language and grammar more easily and naturally. And this develops in stages. And then the interactionist perspective is a combination of both inborn and acquired. It looks at concrete language, then builds on that base and on their environment. Okay, that's it. We're going to do in week 3. The next video you'll find that completes this chapter will be in week 4. All right, everybody. Good luck and keep up the good work. Bye now. Testing 1, 2, 3. Hi, and welcome to week 4, Psychology 2. We're going to look at the continuation on chapter 2, and we're going to focus on intelligence. We're going to look at what is it, some theories about it, and we'll look at intelligent testing, and then we'll touch also on creativity. And as I mentioned in the beginning of last week's video, I mentioned about Wendy and the Williams syndrome and her condition, and Kim Peek. And this whole topic of intelligence is kind of surprising because in a sense we think we understand it, and yet we have different examples of, if you've ever seen savants, if you look up on YouTube Stephen Whitshire, you'll see an example of somebody with a particularly enormous skill set and yet having other weaknesses in other areas. So what is intelligence? And how do we measure it? And do we even measure it accurately? Because do we even really know what it is? Let's find out. By definition, we can look at intelligence as an individual's ability to understand complex ideas, to adapt effectively to the environment, to learn from experience, and to engage in a variety or various forms of reasoning to overcome obstacles by taking thought. So it's a rather broad definition of what is intelligence. But if we look at some of the direction that research has developed over time with about intelligence, we'd start with Spearman. He developed what he called the G factor. And Spearman's term for general intelligence, an ability that underlies all mental operations to some degree. People who are bright in one area tend to be bright in others. The S factors, these were specific intellectual abilities. Spearman's influence seen in intelligence tests such as the Stanford Binet that yield one IQ score to indicate the level of general intelligence. Now, he was one of the initial researchers into this area of intelligence, but he wasn't the only. When we look at Thurstone's 7 relatively distinct capabilities that singly or in combination are involved in all intellectual activities, and he called these primary mental abilities. And they included verbal comprehension, numerical ability, spatial relations, perceptual speed, word fluency, memory, reasoning. All intellectual activities involve one or more of these areas, and believe that a single IQ score obscures more than it reveals, suggesting a profile indicating strong and weak areas. And so we're seeing right off in the get-go a sort of disparity around IQ scoring. On the one hand, Spearman is saying everything can be captured in one score, and here on the other, Thurstone is saying, you know what, if you go only into one score, you're likely losing some of the capability of an individual by having just one score. It needs to be something that's done on a broader scale. Now, someone who explored on a broader scale in more recent time is Howard Gardner, and he has what he calls the 8 frames of mind. It's less focused on factors that underlie intelligence, and it focuses more on the type of intelligences. And developed the theory by studying patients with different types of brain damage affecting some form of intelligence, but leaving others intact. And the savant syndrome, as I mentioned, Stephen Whitshire is an example. He studied a lot of people like him, and where they had a combination of mentally handicappedness and unusual talents and ability. And Stephen Whitshire is an example where he has an outstanding and incredible memory. What he's capable of doing is going up in a helicopter over a city he's never been to, spend 45 minutes going around the city in the air, and then spend a week drawing by memory in extreme detail every aspect of what he saw. And when they go back and check, he's 95% accurate in detail based on just from his memory. And there's lots of examples of savants. believes all forms of intelligence are equally important. That one isn't more important than the other. In fact, each has their own skill set. Cultures assign varying degrees of importance to the type of intelligence. So some, because of where they are geographically and where people live, will find some intelligence will be much more important and valuable than in other cultures where other forms of intelligence might be more important. Various abilities and skills have been valued differently in cultures and periods of history. Now Sternberg, he had the triarchic theory of intelligence, and he divided intelligence into three parts: componential, experimental, and contextual. Componential was more like the analytical, book-smart version of intelligence. Someone who was able to learn details and repeat facts and recover those sorts of information was very smart in that form. Whereas experimental was more the intelligence that was related to creativity, insights, where you would do a lot of divergent thinking, which would mean that you go from an idea and stretch out and go beyond the perimeters to see where this will lead you. Whereas contextual would be someone who would have more common sense. Now, common sense is a bit of a misnomer, that if it was common,